All right, so let's go through this kind of quickly. If it's at 0, 0 is less than or equal to 0, so f of 0 is 3. And a half, well, a half is greater than 0, so that is 2. For the next row, we're using the middle function for g. So again, you have to determine, okay, g of 7. 7 is greater than 3. Therefore, I plug 7 into the bottom equation. So 2 times 7 is 14 minus 1 is 13. 0 is less than or equal to 3, so we get 5. Negative 1 is less than or equal to 3, so and 3 is less than or equal to 3, therefore you get 8. In the bottom row, we use the h function. So negative 4 is less than or equal to negative 2. So half of negative 4 was negative 2 minus 4 more was negative 6. Negative 2 goes into that equation as well. Half of negative 2 is negative 1 minus 4 was negative 5. Negative 1 is greater than negative 2, so it plugs in here. 3 plus 2 is 5. And 6 is greater than negative 2. 3 minus 12 is negative 9. Is everybody okay with the top functions finding points? So each of those points that we got in the top function are sort of like identifying points on a graph. So each of those points represent a point on that graph. So they're like table values, but not a table. And example number 1, this graph has 2 breaking points. So in my table in particular, I'm looking at 0 and 2. And I'm either going to have 1 or 2 points above, below, and in between. So for the top function, negative 2 to 0, that's this function right here. That's a closed circle at this point. And then I'm plugging each of these numbers into this equation here. So on my graph, I have the point negative 2, positive 1, negative 1, 2, and a closed point at 0, 3. This function is going down to the left. In the middle, it goes open to close. And these points here are always this function here. So we are always at a height of 3. So it goes 0 to 3, 1, 3, 2, 3. And then the bottom function is coming from this equation right here. You have an open circle at 2. And then you plug in. So it's 2 times 2 minus 1, 2 times 3 minus 1, and 2 times 4 minus 1. So you have the point 2, 3, 3, 5, and 4, 7. I'm totally up an extra row. I'm sorry, guys. just make that my x-axis. Okay. This example here, and if you want to talk about this, this is a function, and its domain and range are both all reals. Domain and range are both all reals because it's continuing infinitely to the left in the negative direction and increasing infinitely to the right in the positive direction. And here these were open unclosed, so they still pass the vertical line test. In example 2, we have one breaking point. So my table only has one duplicate number at -2. Here's where you have to be careful about what numbers you plug in where. Values smaller than -2 are like -3 and -4. And we're using this function here because these are x values less than or equal to -2. This is a closed circle. So it's -4 minus 4, -3 minus 4, and -2 minus 4. Values greater than -2 are -1, 0, etc. So you would plug in these points to this equation here. So it's -2 plus 3, -1 plus 3, and 0 plus 3. Plot your points. And then, is this a function? Yes. Domain, all reals. Range, however, is y values less than or equal to -6. And y values greater than 1. And that is one notation. The easier notation would be to put it into parentheses and brackets. So -infinity to -6, bracket because it includes -6, and then parenthesis 1 to infinity. This function would be 1-to-1 because it passes the horizontal line test. So the reason I've been focusing a lot on the domain and range is because in these next examples, all I have is the graph. And what I need to do is determine the slope, the y-intercept, as well as the breaking points. So what I first start with is, okay, where does each part of the graph begin? So this graph here has an open circle. It's facing downwards. So in terms of the x values, this is -infinity to -1, not including -1. So in my description of this piecewise, and we'll call this graph f of x, this blue segment is going to be all x values less than -1. So I haven't filled in the formula for it yet, or the function value. The other graph starts at +1 with a closed circle and then continues to infinity. So its equations are going to fall into x greater than or equal to 1. So that means the domain of this graph is -infinity to -1, not including -1, and 1 to infinity. The slope of the blue graph is up 1, right 1, up 1, right 1. It appears that it would go through 0, so that would be my y-intercept. So the equation of the blue line is x. So in our piecewise, we would write x, x less than -1. So what that means is any x value less than -1 plugs into the equation f of x equals x. The pink graph is going up 1 and over 2. So it's rise over run. So that means my slope is 1 over 2. And then you would need to know your y-intercept. So that would be like down 1 and left 2. So you could see that it intersects at 3.5. If you don't want to do it via the graph, you could actually take point A and point B, and you could plug into point slope form. So you could say y minus y1, which is at 1, 2, equals 1/2 x minus 1. And you could use point slope form from our previous units and work backwards and get it into slope intercept and see that you get y equals 1/2 x plus 3/2. Okay? Well, let's look at another one, because the first one's always like, let's try again. Okay, down here, we have our blue equation, which is right here. It's a solid line segment going to infinity. In the middle, we have a closed point and a line to a second closed point. And then it ends with an open circle line segment to infinity. So this piecewise function has 3 parts. Our breaking point is at -2 and +4. So in my function, Graph 1 goes from negative infinity to negative 2. It's open, so that means its x values greater than negative 2. Sorry. Less than. And then in the middle, it's negative 2 to 4. And both are closed, so both are equal to. I also don't like that I didn't do that in blue. And then here, it's x values greater than 4, but not equal to. The top and bottom function are really easy because these are horizontal lines. So you just need to know the value of y. So that is at negative 3. So this equation is just negative 3. The other value is at 5. And then for the middle, what's nice about this one is the y-intercept is 0. So all I have to do is concern myself with my slope, which again is up 1 over 1, up 1 over 1. So the equation of my line is x. This is a function because it passes the vertical line test. Its domain is all reals. Its range is the set 3, negative 3, and positive 5, as well as values from negative 2 to positive 4. Yeah, but there's no values from negative 3 to negative 2. These are like sets. These are just saying y equals negative 3 and y equals 5, as well as all values from negative 2 to 4. Yes. Are we okay? So your homework is very similar. It's a bunch of graphs. For this example, they meet at the origin. You can choose which one is the open or closed. And then just down here, since I made these kind of in Word for you, like the open circle, even though the line is in there, it's an open circle at that point. And like this one is an open circle at this point.